everyone. My name is Nidhi Singh. I am assistant professor in the Indian School of Pharmacy at the University, Jaipur. And today we are going to discuss the topic that is the classification and nomenclature. And this is your first unit in pharmaceutical organic chemistry first. So today we are going to classification. Today we are going to discuss the classification and nomenclature of organic compounds. So let's start. So the learning objective of today's topic is that here we are going to learn about the organic compound, like what are the organic compounds, and also we are going to study about the classification of organic compound, and the student after understand they will going to know about what are organic compounds. They will also learn about how we can classify them. Means here that what are the organic compound, what are the classification of organic compound, what are the chemical formula of organic compound, what are the structural, what are the your formula, what are the priority, and what is the how we can classify them, how we can name them. So this all we are going to study in this topic, that is the classification and the nomenclature. In the classification, we will classify the organic compounds, and the nomenclature portion, we are going to name the organic compounds. So let's start the topic. So here, an organic compound is generally any compound that contains carbons. So all the organic compounds that are present, um, they are generally the chemical substances or the chemical compounds, and they all are containing the carbon atom in them. Means they are having the carbon. They are all the organic compounds are all made up of your carbon. So due to the carbon ability to form chain with other carbon atoms, millions of organic compounds are known, and the studies of the property of and synthesis of organic compound is known as organic chemistry. So here, an organic compound is generally any chemical compound that contains carbon. Means here that it is an organic compound that is containing carbon, and it has the ability to form chain with the other carbon atom. So here millions of carbon compounds are known. So here every body which is present on earth, that is all are made up of this carbon, and these carbons have the ability to form chains. So they are having the ability, these carbons have the ability because they are having the molecular number, that is the atomic number is 6, and then we will just electronic configuration, and its number is 2, 4. So it is having 4 in the outermost orbit, and it is having the capability to form bond with the other atom. So here the carbon ability is to form chain with the other carbon atom. So millions of organic compounds are known. So here millions of organic compounds are known, and the study, and if we are going to study of the properties and synthesis of these organic compounds is known as your organic chemistry. So here we are going to study about these properties and the synthesis of organic compound, and that is known as your organic chemistry. So organic chemistry, in the organic chemistry, as you all know, that we study the properties and the method of operations, how the organic compound are formed. Next, we also study about the chemical reaction, means what chemical reactions they are giving. So they are that is known as your organic chemistry. So whole uh, this whole thing means the organic chemistry is the chemistry in which is the science, or you can say the organic chemistry is the science which deals with the study of properties and the synthesis of organic compounds, and the carbon has the ability to form chain with other carbon atoms. That is why there are millions of organic compounds are known. An organic compound is generally any chemical compound that is containing carbon. So here the classification of organic compound is that based upon the structure, means what the structure of this organic compound is, they are classified into two types. So here they are classified into two types. One is your acyclic compound and the second is your closed compound. Or you can say the cyclic compound. So on the basis of the structure that how they are connected, are they forming a chain or are they forming a cycle or are they forming a closed cycle? Okay, so here they are classified on the basis of these organic compounds are classified on the basis of their structure, and they are of two types. One is your acyclic compound and the second is your acyclic compound. Cyclic compound is your closed chain and the acyclic compound is your open chain. So acyclic are containing the chain, that is your the chain can be small or large. So here the chain, uh, the acyclic compound, acyclic means A is attached to the cyclic. It means they are forming a open chain, and the cyclic compound means they are forming a closed chain. So here classification of organic compound, the cyclic compound, they are forming a closed chain, and the acyclic they are forming a organic chain. So the organic compound is generally an organic compound is generally any chemical compound that is containing your carbon. So the carbon has the ability to form chain with the other carbon atom. The million of organic compounds are known, and the study of the properties and the synthesis of these organic compound is known as your organic chemistry. And the classification of organic compound based upon the structure based upon the structure, they are classified into two types. So acyclic compound and the cyclic compound. Acyclic means they are having the open chain and the cyclic compound means they are having the closed chain. Next, you can see this is the organic compound. So they are divided into two categories, that is the open chain or the cyclic acyclic, or you can say them the aliphatic compound. And next is the closed chain or the cyclic compound. So the organic compounds that are containing the carbon and they are divided according to their structure, capability of forming a structure. So they are divided into two categories. First is your open chain and the second is your closed chain, or you can say the open chain is saturated compound or the aliphatic compound, and closed chain you can say them the cyclic compound. So these closed compounds are containing again are classified into two types, that is your homocyclic and the heterocyclic. So in the homocyclic they have the ability again has the ability to divide and classify into two types, that is your acyclic and the aromatic. And the heterocyclic are those compounds which are containing the other atom also in the presence of your or means in the presence of a carbon, there are other atoms are also forming taking a part in the ring, like in the furan. So you can see here that the furan is having the oxygen. So the furan is having oxygen present in that structure. So it is taking participation in that structure. Its name is furan. So with the oxygen, there are carbon atom also. So this is a heterocyclic. So second in the pyrrole, you can see here that the nitrogen is taking part in this thing. So it is with the carbon atom. So it is also a heterocyclic and the thiophene. Thiophene, it is having the sulfur. So this sulfur is also taking a participation in this heterocyclic ring. So it is also a heterocyclic compound and it comes in a closed chain or the cyclic compound. So here these all are aromatic. These all are also aromatic means they are following the alkyl rule. So here the homocyclic is classified into alicyclic and your aromatic, and the alicyclic is again divided into this alicyclic and the aromatic is again divided into two categories. That is your benzenoid and the second is your non-benzenoid. So in this homocyclic, you can see first the alicyclic. Alicyclic means they are only containing, because these are the closed compounds. They are the cyclic chain compound, and they are not containing any double bond or the triple bond in their ring. So they are the alicyclic compounds because they are containing only the single bond in their structure. So these alicyclic compounds, you can see the example is your cyclopropene. Cyclo means here the cyclic, and the propane means here that they are containing the three carbon atoms. So in the triangle, you can see they are having three carbon atoms that are attached to each other. Second is your cyclobutane. So in the cyclobutane, you can see that there are four carbon atoms are attached to each other, and that is why the name is a cyclobutane. Cyclo means a cycle, means they are in a closed chain, and butane because they in this structure, in this square structure, you can see they are having the four carbon atoms which are forming a bond with each other. And then is your cyclohexane. So in the cyclohexane, they are having this hexane, and in this hexane, they are in this the six carbon atoms are attached to each other, and they are having a cyclohexane. Means the hexane is having the six carbon atoms that are forming a bond with each other. Next is your aromatic. So in the alicyclic, you have seen the examples is your cyclopropane, cyclobutane, and the cyclohexane. Now in the aromatic. So in the aromatic, you can see this is a benzenoid and the non-benzenoid. So in the benzenoid, you can see these are the benzene ring. So here it is containing a benzene ring and the naphthalene. So these benzenoids are the aromatic compounds, and these are found in the alkyl group also. And these benzenoids, these are containing the benzene ring in them. These benzenoids are having the benzene ring in them, and they are having the unsaturated, means they are having the double bond in their structure. So they are the benzenoid compounds. So here these benzenoids, you can see they are having the benzene ring, and in this these are the naphthalene, these are the fused aromatic compounds, because they are in this the two benzene rings are fused to each other. So this is your fused aromatic compound. Next is your non-benzenoid. So in your non-benzenoid, you can see they are not containing the benzene ring, but they are containing the double bond, as well as they are having the other atoms also forming a bond, or the other functional groups are attached to this. So that is why they are known as non-benzenoid, because they are containing the double bond in them. Means they are also containing the free double bond in them, but they are not forming a that resonance is not occurring in these non-benzenoid. That is why they are known as non-benzenoid. But in case of the benzenoid, there is a occurrence of the this resonance. So in this, the benzene, they are having the resonance is happening in this benzene, but in the non-benzenoid, you can see here, they are not having any resonance is not happening in this non-benzenoid. So here the organic compound, again, the organic compounds the which are containing the carbon atom in them, means they are having carbon and hydrogen in them. Necessary, there is a carbon and hydrogen is present in the organic compound. So they are divided into two categories. One is your open chain, and the second one is your closed chain. So in the open chain are acyclic or aliphatic compounds. Aliphatic here means that they are containing the both saturated as well as the unsaturated compounds. Means the example are your alkane, alkene, alkyne. So they are containing the open chain compound, means they are forming a chain. So it does not depend if the chain should be small or the chain should be large. So they are the open chain means they are containing an open chain. It can be a large chain, or it can be a small chain. So in this, the open chain or acyclic or a aliphatic compounds. That is why they are known as aliphatic compounds. Second is the closed chain or cyclic compound, means they are containing the closed chain or the cyclic ring, cycle ring. The compounds, they are the compounds that contain the cycle, so they are known as your closed chain or cyclic compound. The compounds that are containing the open chain, or you can say alicyclic or the aliphatic compounds, they are known as aliphatic compounds or the open chain or the compounds. So example of this open chain are the alkane, alkene, alkyne, and the example of this closed chain are this homocyclic means the benzene, heterocyclic, cycloalkane, cyclobutane. So this closed chain are divided into again the two types, that is your homocyclic and the heterocyclic. So the heterocyclic, in the heterocyclic they are containing another atom with this carbon atom also. So here there is a presence of another atom plus your carbon atom. So these are the heterocyclic compounds and they are your aromatic compounds. As you can see, there is a resonance is happening here because these atoms which are involved in this thing like oxygen, nitrogen, sulfur, they are having the electron pair, they are having an electron pair in them. So they are containing a electron pair on them. So that is why they are all aromatic because in them, in their structure, there is a resonance is happening in them. Next, this homocyclic is divided into two types. That is your alicyclic and your aromatic. Means alicyclic means they are not having any double bond in them. All the carbons are attached with a single bond. So they are your alicyclic compound. Next is your aromatic. So in the aromatic, they are divided into two types, that is your benzenoid and the non-benzenoid. So in the benzenoid, you can see here, they are having the benzene, naphthalene, and in the non-benzenoids, they are having tropylone. Example is your tropylone. So in the alicyclic, they are not having any double bond or the triple bond. So they are having only single bond and these single bonds are attached with them. So these single bonds are attached or form a bond with the other carbon atom with a single bond. And in the aromatic, these aromatic in this, there are two types, that is your benzenoid and the non-benzenoid. And in the benzenoid, they are having the benzene ring and the naphthalene and this the benzene ring. In the naphthalene, both of them are close to each other. Next is your non-benzenoids. In the non-benzenoid, you can see that they are having the tropylone. So tropylone is not showing any resonance. That is why they are non-benzenoids. Next is the cyclic or closed chain compound. So cyclic or the closed chain compound. So in the cyclic, you can see the cyclic or closed chain compounds. These compounds contain one or more closed chain or ring of atom in their molecule, and in these cases, two terminal carbon atoms are linked with each other in order to form a closed ring. So there, these compounds are containing one or more or closed chain. These compounds are containing one or more closed chain a ring of atom or in their molecule. So in these case, two terminal carbon atom are linked with each other in order to form a closed chain. So in this, you can see here that the cyclic or the closed chain compound are the compound which are having. So these cyclic or the closed chain compounds, these compounds are containing one or more closed chain or ring of atom in these molecules. So here in these compounds, these are containing one or more, means if in this they are containing one closed chain or the more than one closed chain. So here all they are containing a ring of atom. Once the atoms are connected in a ring in the molecule, and in these case, two terminal carbon atoms are linked with each other in order to form a closed ring. So in this cyclic compound or the closed chain, in this the terminal of the carbon atom, means the end of the carbon atom, are linked with the other carbon atom, and they are forming, and the linking of that carbon atom, they are forming a closed chain. So this cyclic compounds, these are containing one or more these compounds contain one or more closed chain and closed chain or ring of atom in their molecule. So in these cases, two terminals. In these cases, two terminal carbon atoms. In these cases, two terminal carbon atoms are linked. In these cases, two terminal carbon atoms are linked with each other in order to form a closed ring. In order to form a closed ring, and it can either be a three, four, or five member ring. So these cyclic or closed chain compounds, these are having either in these cyclic or the closed chain compounds, in these the two contaminant carbon atoms in which they are linked with each other, they are forming a closed chain, and in this they are forming a three, four, or five membered ring. If they are forming a three, four, or five membered ring, for example, is a cyclopropene, cyclobutane, cyclohexane. So these are the compounds. The cyclopropane is a cyclic compound, and it is a three-membered ring. And in this, the three carbons are linked with each other, and they are forming a closed chain. Next example is your cyclobutane. And in the cyclobutane, you can see the three the four carbon atoms are linked to each other. The four carbon atoms are linked to each other. The four carbon atoms are linked to each other. And in this, the four carbon atoms which are linked to each other, they are forming a ring, and they are forming a ring, and that is why they are a cyclic or a closed chain compound. Next is your five membered, and this is your six membered compound cyclohexane, because they are containing a six carbons. The six carbons are attached. The six carbon are attached with the terminal, and they are forming a six-numbered ring. Means they are connected with each other. The six carbon atoms are connected with each other, and they are forming a ring. And that is why they are known as cyclohexane. Cyclo means a cyclic chain, and hexane means that they are containing a six-member, six carbon atoms are present in one. And the compound with only one ring of atom in the molecule are known as monocyclic, but those with more than one ring of atom are termed as polycyclic. So here, the compounds which are having only one ring, they are having only one ring, then they are known as a monocyclic, and the compounds which are having more than one ring of atom, then they are known as your or polycyclic. So they are known as polycyclic. Poly means many. So here, they are known as your polycyclic. And in the cyclic or the again cyclic or the closed chain compounds, these compounds contain one or more closed chain. These compounds, cyclic or the closed chain compounds, these compounds contain one or more closed chain or ring of atom in their molecule. They act, this line says that the compounds that contain one or more closed chain means here they are containing एक या एक से ज्यादा closed chain or ring, एक या एक से ज्यादा closed chain or the ring of an atom in their molecule. And in these cases, two terminal carbon atom means if the two terminal carbon atoms, the end of the two carbon atoms are linked with each other, in order to form a bond, means they are forming a bond. Then they are forming a closed ring. So they are forming a closed ring. So in these cases, two terminal carbon atoms are linked with each other, and in this In order, they are forming a closed chain. Next, it can either be a 3, 4, 5-membered ring. And for example, is that cyclobutane because it is containing a 3-membered ring because in this the 3 carbon atoms are linked with each other and they are forming a closed chain. Next is your cyclobutane. So cyclobutane is having a 4-membered ring, and in this they are having the carbon atom. The terminal of these carbon atoms are linked with each other, and in order to form a closed chain. Next is your 6-membered ring, and in the 6-membered ring you can see that the 6 carbon atoms are attached to each other and they are forming a closed ring and they are forming a closed ring. So they are forming a 6-membered closed ring. The compounds with only one. So the compounds which are having only one atom in the molecules are known as monocyclic. So the compounds which are having only one atom in the molecule are known as monocyclic, but those with more than one ring. So here, if they are containing more than one ring of atom, then they are known as your polycyclic. So the compounds with only one ring in the molecule. So one ring in the molecule. It means that if they are containing the molecule which is containing only one ring in their structure, they are known as a monocyclic, and if they are containing the 2 rings, more than one ring, or you can say the 2, 3, 4, 5, 6 rings in a molecule, then they are known as your polycyclic, polycyclic, uh, polycyclic ring. So this is your, this is divided into 2 subgroups. So it is divided into the 2 subgroups, the cyclic and the closed chain. That is a homocyclic or carbocyclic or the alicyclic. Sorry, this homocyclic, they are divided, the cyclic or the closed are divided into your 2 types. So first is your homocyclic. So in the homocyclic or carbocyclic, these are the compounds having a ring of carbon atom only in a molecule. And the carbocyclic or homocyclic compound may again divide into 2 types. That is your first is your alicyclic and the second is your aromatic. So in this homocyclic, these are the compounds. So these are the compounds, homocyclic are the compounds that are having rings or rings of carbon atoms only in the molecule. So in a molecule, they are having only the ring or a ring of carbon atom. Means they are showing the structure of a ring, means like your cyclobutane, or in this you can see carbons are connected with each other, like CH2 bonded with CH2, then they both of the CH2 are connected to the third CH2. So either they are showing like this structure or they are showing a ring chain. Sorry, a ring is shown. So these homocyclic or carbocyclic. Carbocyclic means here that they are containing a carbon cycle. So the carbons that are showing a carbon cycle, they are known as carbocyclic, and the homocyclic means they are containing a one chain, that is a homosingle cycle. So that is why they are known as homocyclic. So these are the compounds they are having a ring or ring of carbon atom only in the molecule, and the carbocyclic. The carbocyclic or homocyclic compounds may again is divided into 2 types. So this carbocyclic or homocyclic are the compounds. These carbocyclic or homocyclic, it may be divided into 2 types. That is, first is your alicyclic compound. First is your alicyclic compound, and the alicyclic compounds. These are the compounds which contain. These are the compounds which are containing in a ring of 3 or more carbon atoms. So here, alicyclic compounds, these are the compounds, they are having a ring of 3 or more carbon atom. Means in them, in the alicyclic compound, the starting cycle starts from the cyclopropane, because in the ethane there are only two carbon atoms, and two carbon atoms can form only a chain. So here the compounds, they are containing a ring of carbon atoms, three or more carbon atoms. So they are containing, these are the compounds which contain three or more carbon atoms, and these are resembling with aliphatic compounds, and the compounds in many respects. So these alicyclic compounds are resembling the aliphatic compounds. These are resembling the aliphatic compounds in many respects, and that is why they are named as alicyclic. So that is why they are named as alicyclic. That is your aliphatic cycle. So these alicyclic are resembling many characters of them are resembling these aliphatic compounds. That is why they are named your alicyclic, that is aliphatic cycle, or you can say the aliphatic cycle, and these are also termed as polymethylene. So these are also termed as your polymethylene, and some of the examples are. So the homocyclic or carbocyclic, these are the compounds that are having a ring or ring of carbon atoms, a ring or a ring of carbon atom only in the molecule, and the carbocyclic or homocyclic compounds may again be divided into two types, and that alicyclic compounds, these are compounds that are containing three or more or carbon atoms, and these resembling with aliphatic compounds, and these compounds in many respects, that is why they are known as that is why they are named as alicyclic. And this alicyclic, or you can say that is your aliphatic cycle, and they are also termed as your polymethylene. And some of the examples are the cyclopropane, cyclobutane, and the cyclohexane. So they are known as your polymethylene compounds. So polymethylene because they are having the more than one carbon atom. So next is your, because in this there are three methyl groups are there. In CH2, CH2, and CH2 are connected with each other in all these three. So that is why they are known as polymethylene. Methylene is having the structure CH2. CH2. So CH2 is present in this cyclopropane in the three place. So they in the three place they are connected with each other, or they are forming a bond, and they are forming a cycle. So that is why they are also known as your polymethylene. Next is your aromatic compound. So in the aromatic compound, these compounds consist of at least one benzene ring. So these aromatic compounds are containing at least one ring, that is six-membered carbocyclic ring having alternate single and double bond. So in the aromatic compound, these aromatic compounds, they are containing they should consist of so aromatic compound, they should consist of one or more benzene rings. So here in these they should contain one benzene. I mean they should at least they are having a one benzene ring, that is your six-membered carbocyclic ring. So they are having a six-membered carbocyclic ring, and that carbocyclic ring should have a bonding. They should have alternate single and a double bond. Because in the aromatic compound, or you can say in the benzene, you can see a alternate single and a double bond. So there is a those these compounds should contain at least one benzene ring, that is a six-membered carbocyclic ring, or they should have alternate single and a double bond. So generally these compounds have some fragment order, and hence they are named as aromatic, because in the Greek word aroma meaning sweet smell. So generally these compounds they are having they have some fragment order, and hence named as aromatic. So these aromatic compounds, that is why they are known as aromatic, because aroma is attached to it. So aroma means here sweet smell. So that is why they are having some fragrance and the smell or the odor. And so these compounds may again be divided into two types. So these aromatic compounds, they are divided into two types. First is your monocyclic aromatic ring compound. Second is your polycyclic aromatic ring compound. So these are also called benzenoid aromatic. So these aromatic compounds, they should consist at least one benzene ring. They should contain at least one benzene ring. That is your six-membered carbocyclic ring. That is your six-membered carbocyclic ring, and they should have alternate single and the double bond. So here there should be at least alternate single and the double bond, and generally these compounds are having some fragment odor, so they are having some smell, and hence they are known as aromatic. So in the Greek word, the aromatic aroma means your smell, sweet smell. So these compounds are again divided into two types, that is your monocyclic and the polycyclic aromatic ring compound. And they are also known as your benzenoid compound. So they are containing a benzene ring, that is why they are also known as benzenoid aromatic. Aromatic because they are having a sweet smell in them. Next, these are some of the examples of the monocyclic aromatic ring compound and the polycyclic aromatic ring compound. So in this, you can see benzene is a monocyclic aromatic ring compound because they are containing a single ring. They are having a single ring. This benzene is having a single ring. Next is a toluene because in the toluene, they are having um, only one ring and the CH3 group is attached to it. So that we are not seeing. So we are only seeing the ring. So how many rings are there? So these are the monocyclic compounds because they are containing only one aromatic ring in them. And next is your polycyclic aromatic ring compound. In the polycyclic aromatic ring compound, they are containing only the double or the triple rings. As in case of indane, you can see there are two rings are attached to it, and in the naphthalene they are attaching. But they are in this naphthalene there are two benzene rings are fused to each other in the naphthalene, and in the biphenyl. So in the biphenyl there are two benzene rings that are fused to each other by a single bond. Next is yours anthracene. Then in the anthracene you can see in the anthracene, there are three benzene rings are attached to each other, and they are known as your anthracene. Next is your phenanthracene. So in the structural difference you can see between the anthracene and the phenanthracene, but three both are containing the three rings. So in this, they are containing the three rings in them. So they are the polycyclic aromatic ring compounds because they are containing more than one aromatic ring, and in the monocyclic they are containing only the one more aromatic ring is present in them. That is why they are known as monocyclic aromatic ring compounds. And the example of this monocyclic aromatic ring compound is your benzene, toluene, xylene, and xylene, orthometaparazine, and etc. And in case of a polycyclic aromatic ring compounds, they are containing the ring that are fused to each other, and you can see here there is a fusing of this ring. So in the indane you can see, naphthalene you can see, biphenyl you can see, anthracene you can see, and phenanthracene. So these are all the polycyclic aromatic ring compounds because they are containing a means they are containing more than one aromatic ring in them. Next is the non-benzenoid aromatic. So in the non-benzenoid aromatic, these are the aromatic compounds which are structurally different from benzenoid type and are known as benzenoid aromatic. So here you can see that this double bond is also taking participation in this propanone, and these are the non-bentonite aromatic because they are the aromatic. They are also the aromatic compounds which are having a structural unit. So in this, they are having the structural unit because they are different in the structure. And the benzene, you can see they are containing the benzene ring, but in this, they are not containing the benzene ring, and their structure is different. And their structure is different, and they are containing their structure unit is different from the benzenoid type, and that is why they are known as your non-benzenoid aromatic. For example, is your propanone and the ethylene. Next is your heterocyclic compound. So in the heterocyclic compound, the cyclic compounds that are containing one or more or heteroatoms. So they are containing one or more heteroatoms. So that is why they are known as the heterocyclic compound. So in the heterocyclics, they are containing one or more heteroatom, that is your oxygen, nitrogen, and sulfur. So they are your heterocyclic compound because they are containing heteroatoms in them, and the heteroatoms are your oxygen, nitrogen, and the sulfur. So that is why they are known as your heterocyclic compound because heteroatoms are taking participation in the cycle. So they are known as your heterocyclic compound, and they are again divided into two types. And in the non-benzenoids are also the benzenoid compounds, and they are different. They are having a structural unit that is different from the benzenoid type, and they are known as your non-benzenoid aromatics. And for example, is the propanone and the azulene. And the heterocyclic compounds, they are containing one or more heteroatoms, and that is in the ring, and they are known as your heterocyclic compounds. So they are divided into two types. That is your alicyclic heterocyclic compound. So in the alicyclic heterocyclic compound, the heterocyclic compounds which resemble aliphatic compounds in their properties are called alicyclic heterocyclic compound. For example, is your oxirane or epoxyethane, and next is the tetrafurane. So here you can see they are having a single bond in them, but they are having the heteroatoms are attached to them. So in this, the heteroatoms are attached to them. That is why they are known as your alicyclic heterocyclic compound. So in this, the alicyclic heterocyclic compound, the heterocyclic compound means in this heterocyclic compounds which are resembling the aliphatic compound in their properties are known as aliphatic heterocyclic compound. For example, is your oxirane, or you can say the epoxyethane tetrahydrofurane. Next is the 1,4-dioxane, pyrrolidine, and the piperidine. So in this, all you can see there is a single bond is attached. They are attached, the carbon atom are attached with the single atom, single bond. Next is the aromatic heterocyclic compounds. So in the aromatic heterocyclic compounds, the heterocyclic compounds which are resembling benzene and most of their properties are called aromatic heterocyclic compounds. For example, is this. So in this, you can see they are all containing electron pair in them. All the heteroatoms are having the electron the electron pairs are present on them. So they are resembling the benzene in their properties. They are resembling the benzene in their properties. That is why they are known as your aromatic heterocyclic compounds. So they are known as your aromatic heterocyclic compounds. For example, it is having the furane. In furane, there is having an oxygen atom is present in them. Next is your thiophene. They are having the sulfur with them. Pyrrole, they are having the nitrogen with them, and they are the 5-membered ring. And in this pyridine, they are having the 6-membered ring, and oxygen is also having the 6-membered ring. Then is your oxazine, thiazine, pyrimidine, then is your thiene. So these are the aromatic heterocyclic compounds. Next is your classification. So the classification of organic compound is based on the functional group. So our functional group is any atom or group of atoms in a molecule that gives the molecule its characteristic chemical properties. So functional group is present in any atom or group of atoms in a molecule that they are providing its Yeah, a characteristic, then it is giving the molecule characteristic chemical properties. And the double and the triple bond are also considered as functional group. And all compounds with the same functional group belongs to the same class. So the compounds which are having the same functional group, they are belonging to the same class, and the various classes of compound that are having some of the common functional group are listed in the table. That is the way these are the example of some important functional group. Like alkene, they are having a double, alkyne, they are having a triple, alcohol, they are having the OH atom present, or a functional group is present, ketone, they are having C double O, amine, they are having NH2, nitro, they are having NO2, sulfonic, they are having SO3H, and organohalides, they are having the halides with them. Next is the questions. Organic compounds are broadly classified as alicyclic compound and acyclic compound. Aliphatic compound is the other name for or acyclic compound. Which among the following is not an example of acyclic compound, which is C-cyclobutane? Which among the following is not an example of any cyclic compound, that is your acetic acid? Which among the following is not an aromatic compound, that is your pyridine? And find the odd one among the following, that is your branch chain compound. Next, these are some of the references from where you can study this topic, and thank you so much for today's lecture.